Can you hear me now? Okay, sorry about that. So I'm a consultant at Mandiant, which I guess is now FireEye, so I need to start saying I work at FireEye. I spent the past about 3 years doing mobile security research and some tool development. For the past couple of years, I've been working on a project that I've called Cobra Droid, which is basically a dynamic analysis tool to help me do app assessments, similar to Droid Box, if anyone's played with that. And I have my GitHub on here that I have other small tools for people to download and play with. And my Twitter handle's on there, but I don't really use Twitter that much, so not much there. So what this talk is not an audit of the Android open source project. The presentation yesterday about the broadcast receivers was an interesting talk about the Android open source, and I discussed some issues there. It's also not an introduction to Android assessment tools, so we're not going to talk about how to use APK tool or Boxmall or how to talk about re-signing apps. For the sake of this talk, we're just going to assume that we all know that we can reverse applications, we can modify applications, and for all the other things we need on Android, it's all written in C, so we can use IDA if we need to look at that. And speaking of IDA, we're not going to look at any ARM or assembly. We're just going to assume that people know how to write that sort of stuff. So what this talk is we're going to determine where and what to look for changes that the OEMs make on our Android devices. And going a little step further, we're going to talk about where and how malicious users can exploit these poorly implemented features, since a lot of times they're not exactly the most secure features. If you think about it, there's all these devices out there on the market, and they're all trying to be unique in their own way, but they're all starting from the same code base. So, Samsung has feature X that, an HTC phone doesn't have, but the way they implement that feature might not be the best way to do that. And it'll also be just a general exploration of Android platform security, which I feel like is a bit underrated. There's a lot of talks on just application security, but not a whole lot on just platform security in general. So my motivations towards this is, when I started doing this, I was testing devices. I couldn't really find any primers on how to do it. If you're learning how to pen test, or you're learning how to do forensics, you go online, you buy a book, you look at some blogs, you read some sites, and you have a pretty good understanding of where to start. I was kind of in the dark. I couldn't really find any, guides on how to do a device test. I mean, there's great information on XDA developers, but it's not really geared towards doing a security assessment. It's more like how to root your phone, and it's like little tidbits of knowledge, but they're not organized in the methodology that I could use to actually do an assessment. There's also no really free tools for us to use. The only thing I can even think that comes remotely close is the Drozer Pro suite from MWR Labs, but that's a pay-for product, and not something that I was interested in buying. And basically, to answer the question, if someone were to hand you a new phone and just hand you a phone and say, what are the vulnerabilities on this device, where to look for the issues, and what can we use to actually find the issues there. So some of the issues that I'm talking about here are just kind of listed here. So information disclosure is always a big one. Basically, is a malicious user or a malicious application able to obtain information about the user or device using some sort of vulnerability? Is a user able to, or an application able to escalate privileges on the device? So this is where XDA developers focus is are we able to root these devices that come out? And also denial of service. Is it possible for a malicious user to create an application that exploits some issue in a particular device that would render the device useless or cause harm? So we're going to start by talking about the where and the what, where to look and what to look for. And I've kind of broken it down just by type, I guess. So we're going to start, give a quick little setup here. Let's assume that somebody hands you a phone, and this is not a phone that was stolen or something, so there's no lock screen. You have USB debugging turned on. You have a test laptop set up with the ADB, the Android Debug Bridge set up. And let's assume this phone is not rooted. You'd be surprised how powerful the shell user is on these Android devices. You have pretty much all the control you need except running things as root, which is good for doing device assessments. So we're going to start by looking at applications. So applications are a pretty big component of a device. If you think about it, the new Galaxy S5 comes with 37 Android applications, which are part of the Android open source, and 291 applications that are part of Samsung and the carriers' added applications. That's a lot of applications. And when you think about it, one of those has to have some sort of issue. So when we look at the components of an application, we have activities, which are just a visual component. Think of like a dialer application with a touchpad. a service which runs in the background. You can think of like a Twitter updater that runs every half an hour to update your tweets. A content provider, which is basically a database or some sort of information sharing mechanism. A broadcast receiver, which was talked about yesterday, which is basically a listener for some sort of event. A good example of this one is when an SMS message comes in, a broadcast receiver goes out and says, hey, SMS message is here, or hey, the phone has completed booting. There's also native libraries, which I'll talk about a little bit later, but basically these are C libraries that give you the ability to interact with C code from your Java. So components can be exported. The main strength of Android is that you can basically export what you want and other applications can interact with them. It creates a very unique user experience. It allows you to do things like create a messaging application such that when a message comes in and it contains a phone number, if you click on the phone number, it'll launch the dialer with that phone number. That's a nice experience. And the way that's accomplished is by exporting the dialer application so that other applications can interact with it. So now this can be done explicitly by saying, I want to export this particular component, or it can be done implicitly by mistakenly exporting it. So for example, if the application is marked debuggable, everything's exported by default. Or if there's an intent filter present, which is usually basically a filter for the particular message it's looking for, it's automatically exported, regardless if you said it was or not. And it's in the documentation for Android. I think people just overlook that. So it's always important to be careful what you export, because you can really affect the security model of your application by exporting the wrong components. So you always should use permissions. So permissions are a mechanism provided by Android so that you can basically say, I have this component, and I want you to possess permission X or Y to be able to interact with it. So there's already hundreds of permissions defined by Android, and these are included all in the core operating system. For example, receive SMS. You need to possess that particular permission in order for the system to consider sending an SMS broadcast receiver to you. And these are applied at a component basis. And they've provided 4 different levels of protection level. The first one is normal, which really is nothing. It really is just I guess a placeholder. It doesn't really mean anything. Any permission can be defined with normal, and then any other application can request access to that permission. So by setting it to normal, you're not really doing yourself any good. The dangerous would be anyone can request it. However, when a user installs an application with a dangerous permission, it's going to warn the user that, hey, this permission's being requested, and this is something like reading your contacts or sending text messages. These are dangerous permissions. And the final 2 are basically restricted permissions. These are things that the OEMs should be using for all their system-level components, basically saying that you need to be a system application or you need to be signed by the signature of the platform. So anything that was built when the device was built can use these permissions, and no third-party application should be able to use these. You'd be surprised what people actually use. So what I'm going to do is I'm going to go through each of these components and show you how so we encounter some issues here. So I'm going to start with activity, since that was the first one I listed. Usually these are less critical. You know, you're not really going to find an exposed activity that's going to ruin your day on the phone, but sometimes you do. Sometimes you'll find, for example, a parental controls application, where when you launch the application, it'll display a authentication box, and when you put the correct credentials in, it'll launch another activity. Well, if they export the activity that's behind the authentication, it completely bypasses that whole check. You can just directly launch that, and then you're automatically in. But primarily, you see things like debugging screens, hidden menus, that sort of stuff. So I have an example here. You can see there's a permission defined here called secret code IME, and then we see an activity with that permission applied to it. So it looks like, you know, they're doing things right here. But as I mentioned before, there's no protection level here, so it's assumed to be a normal permission. So this permission is doing nothing. It's just saying, hey, this permission is required, but anyone can use this. And secret code IME is a special dialer that has additional privileges on a particular device. So not good. Service is the same thing. A lot of times I see a lot of authentication services where it'll accept credentials, or it'll accept a token and return a token or give you some sort of session ID. Or sometimes you'll see things that just perform some sort of sensitive activity in the background that it shouldn't be. The ones here aren't really anything sensitive. You can see the top one here is exported, which means that you could call the system UI service, which is not an Android service. It's something that the OEM's added. Or the one below it is false, so you wouldn't actually be able to call that one, but I just wanted to contrast the exported true versus false. But it's interesting. Take screenshot service. That's kind of cool. Exposed providers. These are a real big one. You'd be surprised how many applications get installed with databases without permissions or just the wrong permissions. Perfect example is right here. Provider named Parental Control Settings DB Helper. I think it's pretty obvious what that thing does. And this one has a write permission. So you can, with content providers, you can specify read and write permissions. This one chose not to have any read permission, so any application can read from this database. And for write permission, they have Android permission write settings. Again, this looks good, but the issue is write settings is a dangerous permission, which means that when you request this permission in your application, it's going to say, hey, this application wants to use this permission. But it's not going to stop a malicious user from installing an application that requests the write settings permission. So you can only imagine what would happen if you installed an application and it has write settings to the parental controls activity. It's pretty much going to ruin that whole security model. In broadcast receivers, there's a specific type that I'm going to talk about here called secret code receivers. And these are present on all devices pretty much. Basically, it's a special intent filter for a receiver that when you dial a specific code sequence in the dialer application, it's going to send it to whoever's listening for that. So if you launch your dialer and type *##9090 #*#*, it's likely going to send a receiver to this guy here, which is going to launch some activity or start some service or do something. And devices can have anywhere from 10 to 100 of these secret code receivers that are basically the back door to an application. This particular one, you can see here, it's got a permission, which is good. And this permission is actually a system or signature-only permission. However, the OEMs forgot that when you assign this permission to the dialer application and the user is using the dialer application to invoke these, it doesn't matter. You can invoke all of these because you already have that permission as the dialer. So you'd be able to call all these. Is there any questions? Okay. All right. So moving on from Android applications and talking a little about frameworks. So if you've ever developed an application, you know there's this large API of calls you can use. So they have to be installed somewhere on the device, and these are the frameworks. These are both the APIs that you can program off of, as well as the resources they use in your application. So OEMs are free to add whatever they want here. They can add their own resources, their own widgets, their own classes, whatever. And these are going to be loaded up into the Zygo VM at boot. And the Zygo is basically a special instance of the Dalvik virtual machine that every time an application wants to start, it forks off the Dalvik virtual machine, and everything's loaded and ready to go. It's a performance optimization in Android that makes it so when you launch an application, it doesn't have to load the VM up. So it does that by reading the boot class path variable, which is set when you boot the device. So you can see all these jar files here, which are just basically class files, that are all loaded into every virtual machine when you start an application. So I would say about half of these ones on this list here are actually part of the Android open source project, and the other half are just OEM added ones. So if you were to dig through here, like, you know, what is the common IMS interface, or what is the QC media player? What are these calls you can call here? And what you want to do is usually explore each of these APIs and see what's in there. And then what you're likely going to have to do is create like a fake application in Eclipse, and then disassemble that, and then write your own Smiley code, because Eclipse is going to complain that it doesn't know about these APIs since they're not actually part of Android. One of the goals I want to work on is to actually be able to rebuild the Android.jar so that you can use these APIs as if you were a vendor. So if you were developing against these APIs, you'd have them all there, and you could just say, like, read secret here. Like, why is that available to every application on the phone? Or write this ID me here. So you'll see things like this that every application could read if they knew about them, and they're all just there. Some other things in the Android runtime that are interesting. System services. So on the new Samsung Galaxy S5, there's about, I want to say 70 Android system services, and then there's about 50 Samsung or OEM added system services. Like, that seems like an aggressive number of system services in addition to just whatever's on the phone. And these could be anything from, you know, controlling boot to having their own standalone properties class. I don't know why these OEMs want to add their own properties classes when there's already the whole Android properties there and it's a secure model. There's also this file called the platform.xml, which is stored on the system partition. And basically it's a mapping to group, basically two different things. permission to group ID matchings. So what people don't realize is when you request the internet permission, all it's doing is adding you to the group INET. And the group INET is allowed to create sockets, and the regular group that you are assigned to as a default application is not allowed to create sockets. So when you try to access the internet and you don't have the group INET, you fail at the socket level in the kernel. And there's also additional group mappings or permission mappings to a group. So you could say, if you are in the group shell, which is like the debugging group user, you get the permission set debug app. And the OEMs are free to add whatever they want here, even though there's a huge disclaimer in the file that says, be extremely careful what you add here. It's interesting, but there's all kinds of stuff in there that you'll find that they add new groups and they add new permissions to these groups, and it just makes you kind of wonder why they did that. Log buffer is another really interesting one. By default, there's a few log buffers on each device, and there's APIs to interact with them. The one that you're going to use most often, if you use the log class in your application, is the main log. So I have an example here. You just say, my app would be your tag, CarolinaCon rules would be your message, and that's going to show up in the main buffer down here. But just an example here, like it's not hard to figure out who this one is, but there's this one, and there's also metrics here that there are different log buffers that are just there. And what's in Amazon main? Why couldn't Amazon use their own, or why wouldn't they just use the main log, or why are they even logging stuff there? And notice the groups aren't even anything special here. It's the same log group. So if you wanted to read logs, all you have to do is be in the log group, and then you can read all the Amazon logs and all the metric logs. System binaries. Again, this is the dump from a Samsung S5. I think there's 81 system binaries that the OEMs added. I mean, some of these are shell scripts, some of them are ARM, some of them are configuration files, and they're all just in the directory system bins. So going through these, you can understand a lot about where specific files that you wouldn't normally have read access to. So they'll show directories on the system drive by just looking at these, doing strings on each of these. You'll learn a lot about some platform-specific files. And a lot of these are like testing tools that require root access. When you try to run them, and you'll see all these permission errors and things will start breaking. But it does help you kind of understand some of the changes the OEM made at the system level. And going along right with that, native libraries. I mentioned that this was part of an Android application, but we can also have system libraries on the phone. I think there's about 400 in Jelly Bean, or not Jelly Bean, KitKat at this point. And these are just shared libraries, SO files, that basically have C code in them. And some of them have what is referred to as the JNI, which is the Java native interface, which allows Android applications to write code in Java, which talks to the C code to do lower level functionality. And it's interesting to note that all shared libraries, unless explicitly told not to, can be read by any application. So if you have some sort of shared library called generatesecret.so, and all it does is return some sort of token, any application can technically read that shared library and interact with it. And this becomes more of an issue when the shared library does any sort of device driver interaction. Because if it does any sort of device driver interaction, we know we're talking to the kernel. So just an example here, I'm just running a command here that'll print out some of the JNI calls. So this particular format where it starts with Java underscore and then a class name will show you that those are functions that are exposed to Java. And you also see that it imports the socket call, and there's a socket right here, which is basically saying that it's communicating with the socket driver. And this was actually how one of the new HTC phones was rooted. There was an exposed socket driver. There was a shared library that had all these crazy calls that would basically let you do things as the kernel, and you could call that as any application. So it's terrible they would even consider that secure. So now, talking about the where and the what to look for, I'm going to talk a little bit about some tools that I've created to sort of make this a little bit easier. So I mentioned there wasn't really anything that I had found that was going to help me automate this and help me do it on like if I have a new device, I want to do it quickly. So I developed this device testing framework that I've called DTF that just helps me do device testing assessments. It really just spawned from all these scripts that I had. I had Python scripts, I had Bash scripts, I had some C code, just all this junk, and kind of just bundled it all together in this like framework sort of modular-based approach to basically to go through each of these things that I talked about and give me some results to look into. So I wanted to know, I have this device, I want to know all the new system services, or I want to know all the new content providers that are created. I want to know all the new log buffers that are created. And from there, I can use all the reverse engineering tools that we already have available to find issues. So by itself, DTF is not really that exciting. If you think about Metasploit, I mean, Metasploit by itself isn't really that exciting. It's the modules that come with Metasploit. It's the interpreter that's really powerful. But Metasploit really is just a command line tool that just allows you to run modules. Think of DTF as the same thing. It basically has some configuration files for your device. It has like a package installer and some module support. And then there's the modules. And the modules are where we're doing the exciting things. So I'm going to talk a little bit about some of the modules and some of the phases of which I'm defining these modules. You could think of any assessment as basically data collection, data processing, and then data analysis. So in the data collection phase, we're basically collecting files off the phone. We plug in our phone, we set up a DTF project, and then we have these particular commands here that we can call to get stuff off the phone. So you could essentially just chain these together and pull off all these files and come back in half an hour, and you're going to have all the system applications, all the frameworks, all the binaries, all the system libraries, and all the permission files all stored locally for you to use later. But nothing too exciting yet. But then we start processing them. So we have a module that unpacks all of our framework files. So this will put the frameworks into a database and also unpack them all to directories so that we can start analyzing them. Same thing with system applications. It's going to try to unpack, like I said in the case of the S5, 290 applications in addition to the regular ones. And it's going to put them all in their own directories, rename them all nice for us, so that we can start actually playing with them. And then the real fun part is it's going to start creating databases for just about everything that it can. It's going to take all those applications and it's basically going to like index them. It's going to go through all of them and it's going to put all the providers, services, receivers, and activities and shared libraries into databases. It's going to put the permissions into databases. It's going to put the use permissions into databases. It's going to take all the DEX code and it's going to index all of those. It's going to go through and pull out all the class names, method names, the superclass, all that, and put those into databases. So it's going to do the same thing for the devices and the system services. So now, when it comes to data analysis, I've basically done this, the previous two steps, for all versions of Android. So I have a bunch of directories set up with API 10, 11, 12, 13, 19, with all these databases for each level. And then I can say, okay, I have a new phone running KitKat, and I have all these databases that are basically metadata about that API in that phone. And then I have my new device here. I want to do some diffing here. So I want to know all the new devices here. So all I have to run is DTF dev diff, and it's going to print all the new devices that are included on that phone. And with some different flags on the command line, you can show ones that are exposed, ones that are readable for everyone, etc. And you can do this for pretty much everything that I have so far. So you could say, I want to know all the new applications that are installed. So you just run app diff, put it to a file, and then you can go through that and say, okay, I see all these new applications. Then you could say, I want to see all the new framework files. Framework diff, just as simple as that. So a lot of my testing starts from just running all these, and it creates a lot of leads, a lot of things to look into. It's not going to really find any vulnerabilities yet, but what it's going to give you is all the things that you should be at least looking into. And besides just diffing, there's also the whole, looking for exposure. There's some modules that basically just look for readable files on different file systems, look for writable files, look for set UID files, since those are, are good go-to for obtaining root. It'll search for all applications that are installed without a launcher activity. The launcher activity is basically like an icon. So I said there's 291 applications on the Samsung. I can guarantee more than half of them don't even have an icon or any sort of, you would never even see them because they're not launcher applications. So this will print out all the ones that are not launcher, which you should look into those because they might be debugging, they might just be some sensitive, like why are they even there if you're not even supposed to launch them. You can also extract all the app metadata. You'll find a lot of API keys hanging out in manifest by just running this one. And then my favorite is just running these CSV generators here. You can just run all those, and it's going to give you CSVs with all the exposed components in terms of secret codes, any debuggable applications, any exposed activities, services, providers, receivers. You can just throw those in Excel and then start going through them like a checklist and saying, I'm going to launch this one, and it looks like it's some sort of hidden message or hidden menu. Okay, that's sensitive. Okay, this one is just a, whatever, change the URL for this application. But you can go through those, and it's all the data you need in a CSV, which is an easy format to filter and sort and all that stuff. And then in general, there's just some general purpose commands, things that these are basically just scripts that I had that, you know, I wanted to bundle. Oh, question? Yep. So yeah, so there's two ways you can do that. You can do them in the dialer, which can be kind of tedious, but really all the secret code is a properly formatted intent. So you can use the secret code command I have here to make that intent from the command line. You can script it right out. Yep. Yep. Right. So basically, secret code, this particular DTF command is just an intent creator that you give it a number, and it's going to dial that for you. So you could set up a script that just goes through them and will dial each one of them, and make it easier for you. I use Linux for most of the stuff. Yeah, I use Linux as my test platform, which is why I mentioned I use Bash. Eventually, I'd want to get it onto something like Python, like pure Python, so that can be transferred to different OSs. No, so really the only thing that it puts on the device is like a thin client, so that if you want to interact with the device as an application, you can do that, but you don't even have to do that. Most of the stuff is offline. Basically, the data collection phase will get almost everything you need off the phone, so that you can, yeah, puts it all locally. It takes up a little bit of space locally, but then you can pretty much unplug your phone until you're ready to start doing stuff like this, where you want to when you want to start dialing these codes, you got to plug it back in. But the idea is to get everything off so that you have all these databases and files locally, so that you don't need to have the phone in and run any agents or anything on there. Not yet. I forgot to actually mention that. So right now, it's still pretty devy for me. It's like I said, it's all these different things hodgepodge together. When I do feel it's stable enough, it's going to be on GitHub. I think I'm going to put the Apache license on it. So my goal was to have it ready for today, but you know how that goes. So, but yes, it will be on my GitHub. Question? So I use the emulator to build the databases that I'm calling like the Android databases. So that's what I use to like baseline each OS. So like I have an emulator for 1 through 19, and then that's what I use to create these databases. So I mean you could, but if you're asking if you could install like the stuff on the emulator, is that what you're asking? I mean, you might be able to if you played around with it a lot. I mean, then you just make sure the kernel lines up everything correctly there. You'd probably need root privileges to get everything you need off the phone for everything to work. I'm sure it's possible since the emulator is running just Android. It might be more trouble than it's worth, but it's an interesting thought, though. Okay. So basically, these are just some general purpose commands. The one call where I showed that I was printing out the shared library, it's just called libinfo. It just looks for JNI in all your shared libraries, looks for any sort of device interaction, so you can run that across all the shared libraries, and it'll give you like the ones that you should actually consider looking into. Usually for these, if it imports socket or it imports IO control, and it talks to something in the dev directory, and it has JNI, like that's bad. And if you can actually interact with that driver, then you probably can get some stuff to execute as a kernel. New app is an interesting one. I found a lot of times when I'm looking through these APIs, like you find a new framework API, and I told you can't use Eclipse because it doesn't know about that API. You can use this new app one. It just basically forks off a new application with make files that you can just say make clean, and it'll install on the phone. And then you can just start writing in Somali, and then just build with the make files, so you don't have to actually ever even use Eclipse to do that, if you're like writing in Somali for whatever reason. And finally, class search. Because you have everything in databases, including DEX and all of your components, you can do class searches where if you find a class, com Android sensitive, and you want to know what file that's actually in, you could just say class search com Android file, and it only takes 10 seconds, as opposed to running these grep commands across 4 gigs of unpacked files. Quick way to say, okay, it's in this particular framework, or it's in this file. So just some closing thoughts. Looks like I finished up a little early here. To me, it seems like the OEMs and the carriers, they have a lot to learn. These issues are like 1999 style. They're not like memory corruption. They're not like this crazy turbo hacking kind of things. They're just like things are just exposed and they're there. And I think it's just the fact that there's really no tools out there to find this stuff yet, that they're not being found. But given the right tools, such as the things that I just demonstrated here, it becomes extremely apparent what's exposed. And I mean, I've been doing my best to try to report things that I can to the OEMs. You know, they'll argue the severity all day, but there's a lot of things I think the OEMs have to learn about platform security. So just be careful how much trust you put in your devices. I mean, there's, like I said, 300 applications on there. Each have their own security model, and not all of them are perfect. So, any questions about anything so far? Sure. No. Mhm. Okay. Mm-hmm. Yeah, you're not alone there. Yep. Yeah. So I'm not entirely sure how that particular app works, but there are a lot of methods to do that. If anyone's done any iOS programming, there's the mobile substrate. Basically, it's a hooking framework in the Objective-C code. That was ported over to Android. It requires a rooted phone, obviously, but basically when the Dalvik machine loads up your application, it'll throw hooks in there so you can hook functions at that point. And it could be doing something like that to hook when the application starts and look for the permissions and deny at that point. Or you could modify the package installer, which I think was mentioned yesterday. You could modify that to look at the permissions that it's requesting and then rewrite things. I mean, there's all kinds of things you could do. Once you have root, I mean, the sky's the limit. You can rewrite system binaries at that point, and then you could use that to do that. But that's like, I think 90% of people's gripe with the Android cloud permission model is that you can't just say, no, I don't want you to use my location. It's like it's all or nothing. So it is a pretty big concern, I think, for a lot of people. So, yeah, question? I've looked at the Galaxy tablet, and there's definitely some added things on there. I haven't looked at any like the Nexus phones. I would imagine that it's going to be less bloated than like a Samsung or an LG or something, but there is still, I'm sure, some changes. I mean, if it was just stock Android, it might actually be just pretty much stock. That's an interesting thought because I haven't actually looked at any of the Nexus phones to see what they got going on, but yeah, I might have to look into that. So, question? In terms of you saying like security improvements in KitKat? So just an example right there, the shared library one is still not, it's not really like an issue, it's just something that you need to realize, so that's not fixed per se. I don't know why, but they had in I think the Jelly Bean versions of Android, they had this whole app ops, I think it was some sort of hidden functionality that people found, and then they stripped it out in KitKat. Oh, that was designed to, I think, do what the gentleman over here was saying about denying permissions, but the Android devs actually pulled that out in KitKat, like entirely removed it from the Git tree. I haven't seen any, like, there are like security improvements in KitKat, but I haven't seen any at like the platform level that would make the overall experience be a little bit stronger. One thing I've heard, and I haven't really confirmed this, but the new version, whatever they're going to call that, is going to prevent execution on the data partition, which will impact the way I'm getting a lot of data. Basically, you can't export really anywhere else. They made it, you used to be able to export like from the dev directory, from the data local directory, but in the SD card you used to be able to execute off of. Now that's all been disabled. They're all mounted read-only, and they're considering mounting the data partition read-only. So it's very hard to actually run commands as different users on the data partition. And there's also, actually one thing, there is SC Linux running on KitKat. So there is that whole model. Some devices I see, they have it in enforcing mode. Sometimes it's just in like whatever like the other mode that SC Linux has, like learn or whatever. But that was a big improvement in the new versions of Android. That makes it a little more difficult to gain access to specific files as opposed to just using the Linux permission model. Any other questions? Sure. I don't think so. I mean, the mirror, that's fine. There really isn't any agent that I know of, besides like some of these MDM solutions that claim to make your data more secure. I know like Blue Box has one. I want to say FireEye has one coming out, but I'm not actually sure how those apps work. I'm actually really curious to see how they're able to do some of the sensitive things. I mean, yeah, and it's as an application, you can do less than you can at the command line. The command line users pretty much almost root, but the applications are restricted in several ways, so that if they're able to do all these things as an application without being installed as like an MDM or like an administrator app, I'd be pretty curious to see how they're doing that and to see how that all works. But I haven't personally played with any. Most of those are like paid-for solutions that I don't get any exposure to, unfortunately. So, yes. So if you're asking if like a particular app wants to use the camera but doesn't specify the permission, is that what you're asking? It's actually a great example, and I actually did see an application, and I worked with the app creator to fix that. One of the big changes in KitKat was that you now could have a default messaging app. So all the vendors and even third parties are having apps that replace the text messaging app. So they've opened up this whole messaging development opportunity. And what the issue that I reported actually was that it was a new app that was meant to be installed on newer KitKat devices, and it had a service that was protected with a permission that didn't exist on previous versions of Android. So on KitKat, you were fine. If you installed this application on any device prior, because the permission didn't actually exist on the operating system, you can still say, hey, you need this permission to get there. But the system's like, I don't even know what that is, so come on in. So if you were just a malicious application, you could say, hey, I'm going to define that permission, and I'd like access to it, and then I want to talk to that service over there, and you could send text messages as a lower user. So like it does exist. I mean, it's interesting that they're moving to this model where they're trusting the apps to do things like this, and they're just not doing it correctly. The change was 2 lines of code, basically to check if the API was lower than 19. If it is, then just return. But they didn't have that there, and that's pretty funny. Question? Yeah, so what I want to do is exactly that. I want to have the tools out there and the modules that I think are appropriate. And I do want to have either on my website or my blog some sort of methodology, because for one, I like to have it written down for myself, but also to share some of the testing details. And basically, these slides will be available too, obviously, but kind of walk through some of the things that I find useful to doing these assessments. So test cases might be included. One of the thoughts that had crossed my mind, but I don't know how feasible it is for me, would be to build my own version of Android as like a broken web app thing, if you will, so that you could download that and then look for vulnerabilities there. I mean, that's way down the pipeline. I want to get the tools a little set. But yeah, the idea would be to have examples and stuff like that anywhere that I can without, you know, exposing vulnerabilities that are still active. But that would be the goal to do that. Any other questions? All right. Oh, sorry. Well, initially when I had planned on doing this talk, I had reported like 5 vulnerabilities on one device, and I really wanted to do like this whole talk focusing on like specific examples of this device and all the issues there. So I started the whole process before I even submitted the call for paper here, I think it was maybe January, and I said like these are all like serious issues. They're privilege escalation, information disclosure. Let's get them fixed. And they're like, oh yeah, we've created a ticket for you, and we're gonna start fixing them. And I mean, here it is, you know, almost June, and they're not fixed. So I didn't want to like talk about them up here, but sometimes they're really diligent about it. Sometimes they're like, yeah, we're working on it. Your ticket's still open. It's like, it's been 6 months. Like, I mean, eventually I'm gonna just, you know, public disclosure on them, but sometimes it really varies. Sometimes companies are really good about it. Sometimes they just don't see the issue with it. So I guess it depends. Any other questions? All right, well, if anybody has any questions, I'm sorry. Not that I've seen. That would be another interesting thing to do to run these tools on CyanogenMod and see how that is. That's another actually really good idea. But I haven't seen any. There has been some vulnerabilities disclosed in CyanogenMod. The whole updater not authenticating SSL certs, or not validating SSL certs was a big issue. You basically could push any system image down with a man in the middle, so that was a big issue there. But I haven't seen any like sort of documented assessment of CyanogenMod's security model. So yeah, it's another interesting thing to look into. Okay. Well, if anybody else has any questions, I'll be hanging around up here, and I'll be around the con for the rest of the day. So thanks, everybody.